Ladies and gentlemen, hello and welcome to the inaugural episode of what I am sure will be the coolest show in town, Hot Technologies of 2012. Yes, indeed. My name is Eric Cavanaugh. I will be your moderator for today's webcast, all about the rise of analytic platforms. Yes, indeed. So there's a slide about yours truly and enough about me. So this year was hot. Yes, it was hot, folks. I've been in this business really focused on information management and all the various technologies associated with it for about 12 years now, and this was really one of the hottest years I've ever seen in terms of innovation, excitement, all kinds of fun things happening. Of course, the big topic of the year is, of course, big data. We've been hearing all about that. Granted, it has been hyped excessively, but not without some reason. Big data does present an opportunity to significantly change the way people use information, manage information, get insights from information, and frankly, it's a huge change to just the manner in which data is handled and processed. And really what we've seen is this just widespread wave of innovation in a whole variety of different ways. And one of the things, of course, that's really hot these days is this whole concept of analytic platforms. So what exactly is an analytic platform? That's what we're going to try to figure out today. So arguably, these platforms represent the next major phase in the evolution of business intelligence and analytics. And of course, business analytics is a bit outside traditional BI. We can argue semantics if we want, but really business analytics can get down to all sorts of things that make a business run efficiently. Whereas business intelligence largely is dealing with very structured information in tables and database, relational databases and so forth, how many products sold, for in what time period, that kind of thing. But these platforms, so what should they do? Well, there are a couple key things that an analytic platform should do. One, it should really foster collaboration and transparency. It should allow different kinds of business analysts to get to the business analytical needs they want, to basically get to the data that they want, and perform various kinds of analysis. So it's a complicated thing. It's really not an easy thing to do. And then we have this whole different world of big data which sits outside, once again, that traditional relational model of a database. We've heard all about NoSQL databases, NewSQL. Of course, sometimes NoSQL means not only SQL. Sometimes it means it doesn't deal with SQL at all. Of course, referring to the structured query language that is a de facto standard in the way we deal with information. So we want users to be able to access and analyze the data they want quickly and effectively. Of course, we want things like governance baked into that. There's a whole lot of stuff that needs to be accomplished for these platforms to be effective. So we have two analysts online today. It's going to be a lot of fun. So each is going to give their perspective on what constitutes an analytic platform. Then we're going to hear from Walter Maguire, who has been around. He really has more experience in different organizations that do this kind of thing than most people in the business. So he's got a lot of perspective he can bring to the table in telling us what ParAccel is doing and what their analytic platform is all about. So with that, I'm going to introduce Mark Madsen. I'm going to hand the keys over to you, Mark. And with that, the floor is yours.
Thanks, Eric. So I'm just going to take a few minutes up front and give a couple of comments before we roll over to John and Walt. So, the first, I think, philosophical question that comes out when we start talking about analytic data platforms is about data warehouse modeling. And when you think about data warehouse modeling, the choice that everybody picks in the data warehouse world is A, which is you choose the data for your schemas. Very few people actually keep everything. I can't name a single company who dumps their entirety of SAP tables into their data warehouse. The problem is that a lot of times the analytics people who are building models of various types need things that aren't your typical human queryable, I look at these things and report on them kinds of data. And so it creates a little bit of a problem. And so the common situation then for an analyst is that they need information, and this could be either ad hoc or for more serious model building, scoring, and things like that, that they need data that's not or they need data that is slightly different in format or structure than the data warehouse. And then, they spend a long time trying to get it on their own and massage it and process it, or they come to the data warehouse person, and I was data warehouse manager, and it generally took several months to get new data sources modeled in, constructed, and so there's definitely an agility problem. Hey, Eric, can you mute that?
Yeah, I'm trying to right now. Go ahead.
Thank you. When we look at analytics as the use case, it's also a different workload. One of the workload problems, workload mismatch problems between analytics and BI is the data volume, but typically it's not that big of a problem. The problem is that the algorithms require multiple passes through the data, or they take every data element and create a cross product with every single other data element, and you end up with order n squared or order n cubed processing problems, which touch every element in a data set multiple times. Or order n squared simply means that as you increase the amount of data, your processing time increases by the square of that. So even moderate amounts of data, small amounts of data in a data warehouse, if you're using that as your backing store for an analytics platform, it's going to have to feed data at an incredible rate and keep rereading that data while you're doing everything else, all those interactive activities. And the other thing I think that gets ignored in the workload side of things is just that analytics data isn't like a query. It's not read-only. When you're building models, you're doing interactive development. It's more like building ETL than it is doing BI. And so what you have is trying to do things somewhat interactively as an analyst, where you read every single data element in a database multiple times and do a bunch of calculations on it, and then write data back in or pull out sample data sets, process them, train your model, and then validate your model against other data sets. And so you're doing all sorts of bulk copies and movements of data, which is like doing ETL live on a BI system that's trying to show dashboards to people. And that wasn't the design point for a data warehouse. We didn't have this workload in mind back in the late 80s and early 90s when we laid out the proper ways to design things. We built basically a publish and subscribe model where data is published on some periodicity, dumped into the database, and then read back out. And when you look at the kinds of workflows and workloads that go on and what goes on inside a real analytics environment, it gets really complicated. This is a workflow from a paper last year, and it shows the complexity that can crop up as you move data sets and modify them and save test and validation sets that go with the actual training set before you run on the production data. And saving and moving and massaging all of this data everywhere creates that different workload. And then you have the batch versus real-time question. Most people think of analytics, they think of big batch jobs like I just described, but a lot of times that model is now being deployed in a real-time environment where once the model is developed, you're putting it into an application context. So all of this infrastructure is great for building a model or running a batch model, but real-time scoring or real-time fraud detection or ad targeting or whatever you want to talk about takes that model and puts it into a totally different context and a totally different set of technologies. And so you have all of these different needs and requirements, and that really dictates the design goals, which are technically somewhat different because of all of the data movement and the read-write nature. And what that tells us is that you have to decouple the analytic platform from the data warehouse, which historically it has been. Buy SaaS or SPSS, drop it on a server, run it separately from the data warehouse. But really what we're talking about is decoupling the delivery layers and the processing layers from the data storage layers. And in this case, the development, maintenance, deployment, and all of this stuff, it would be nice if you could marry it to the data warehouse database, but have a database that could support more of the storage and retrieval operation than has been historically possible. And that definitely means that we're moving into a distributed computation world. And finally, the production deployment, which I didn't really talk about, gets into how you get these models, put them into production, and run them consistently and tie them in with operations. And to date, most of the messaging has been around an analytic offload where you dump some stuff out of your data warehouse and offload it, or merging the two things together into your data warehouse by simply using in-database analytics, which is an answer for some problems, but not all of them. And so, you know, the answer that is being promoted in the market today is, of course, we'll just replace everything with Hadoop. And I would say be suspicious of anybody who offers that, because while it's good for a certain set of these things, it's not the answer any more than the data warehouse was the answer. So with that, I'll turn it back to you, Eric.
Okay, good. I love those slides. And let's see. Let me go ahead and hand the keys to John O'Brien. And John, the floor is now yours.
Okay, let me move up one to my set of slides here.
Should you be able to click on there and then use the down arrow on your keyboard? There you go.
There you go. How's that?
Looks good.
All right. So one of the things that I really wanted to talk about is that we do have this evolution going on between our classic architectures, like Mark was saying, between the way we've done things in the past. And a lot of the companies that we've been working with and visiting are really asking the same questions with regards to Hadoop. And a lot of times these companies have been playing with or doing their pilots for the last year, getting their hands wet, seeing what the environment's like, and now they're turning towards some planning in 2013, trying to figure out how are we going to get some value out of Hadoop, how do we make it institutionalized and make it part of our BI processes that we want to live with, whether it's from data governance or program management. So for a lot of the architects and technologists out there that we work with, a couple of questions really come up. The first one is this debate, if you will, between how do we integrate between Hadoop and the enterprise data warehouse that we've been living with for many years now, if not decades. So there's what we call, and I'll go over, a two-tier versus a three-tier debate. And I'll try to explain why I tend to be favoring today what I believe is going to be the three-tier generation as the next generation for BI architectures. And then it also opens up the door for the next set of questions, which is where does the semantics live in these kinds of models? Inside the databases, cross-database kinds of things, or in the data virtualization world where we put our context and the things that we want to be shared and consistent above these new data stores. So this is, kind of how we take a look at things, and, with the companies that we're working with, if you will, there are predictions for how the industry is going to continue to evolve in the next couple of years here. So the first one is really recognizing the mixed workload capabilities, orders of magnitude between the traditional enterprise data warehouses, but we've had for nearly a decade now, these good analytic database technologies, from the appliances to the columnars, MPPs in a box, you named it. Then new on the scene, of course, is the key value stores, primarily Hadoop, which we see as really a without context and being more discovery oriented. So the nice things about Hadoop, and the big draw to it, of course, is you've got the highest amount of scalability, the lowest cost factor with commodity hardware and, if you will, open source software, schemaless, meaning without context. So it allows for the best discovery kind of environment. Programmatically, this is how you work with accessing the data. It has complete flexibility, but as a maturity level, it's also an emerging kind of category, only having been around 5 years or less in its adoption. The analytic databases, of course, they're much more accepted today. They're also been around at least a decade or so. They're optimized in their storage persistence layer to be built to do analytics. We know that the old TP world, and we criticized that for many decades, was not geared towards the types of workloads we wanted to do in analytics. So that kind of gave birth to a lot of the analytic appliances that we have today. So we see this distribution of data within the enterprise from enterprise warehouse, primarily reference data management. The EDWs do great at that kind of work. It's a very mature technology. How we want to work with that is multiple sets of types of analytics, and that's kind of the third tier, if you will. Some analysts in our industry, and this is part of the discussion that Mark, myself, and others, or like Walt, will sit down and talk about, is whether or not it's really a two-tier or a three-tier architecture that we see emerging, if you will, as the next generation. Because some of us will, have the discussion and say, well, the analytic workloads can all be done inside of Hadoop. So what's the issue with that? Why don't we just have a simplified, unstructured world, programming batch-oriented, run your analytics, code them, map reduce them, they can run well, and then you can still continue to have your structured world. The problems that I see in the near term, like 2 years, 3 years or more, is the fact that the analytic executions are a bit slower. The analytic appliances and databases built for this are highly optimized and execute several times faster than we do in the Hadoop environment on a whole, because they're optimized for that workload. And then two, going in and having the skill set to develop those analytic models takes longer for the traditional BI teams. The other aspect, of course, is the fact that we've got broad accessibility of the SQL tools themselves, today living more in the SQL-based world. Now, this is the way it is today. Maybe the next 5 years will be a little bit more in this 3-tiered model. Maybe in the long term we see this as an opportunity, but I think we're kind of looking at maybe 5 years down the road. But a lot of analysts talk about this, what's the next generation BI architecture going to look like. I think the other thing that we have here is, where do the semantics live? We hear database vendors talking about their ability to put semantic integrations, leverage HCatalog or Hive, and then allow these SQL users to connect to and query data inside of Hadoop or other databases right alongside them. That's one way to deal with semantic integration, if you will. Analytic databases are a mix between columnar and in-memories, but also, let's not forget graph analysis and text analysis, which live in this category. Or the other approach is to put semantics above, in a layer like virtualization, where BI tools of the future simply connect to HCatalog, semantic discovery perhaps done by data scientists, figure out what those semantic contexts should be, and then promote that to the general public. A combination of services to talk to multiple, storage layers, coupled with our SQL and data virtualization. So we see this combination of which way are we going to go, in database or above database, still being worked out, and we do see that as being a blend. So kind of the things to keep an eye on that we're looking at is really expect these modern BI architectures to evolve in the coming years as these newer technologies, like the one we're going to hear about today, are paving the way for that. Adoption of R for those in-database executions, so it's not about moving data around, it's really about moving the application around. How do vendors push or pull data between their environments? We should want to be executing in the platform optimized, not really pulling the data into another platform just to work on it. And then the final section that we kind of see as a long term is really a term that we're using also and adopting called Polyglot Persistence, which says we really need to store and persist data on its optimal storage platform in those engines and access them with service layers. So we're looking at this migration and evolution along this path, if you will. So it's kind of a real brief take. It's two things. It's this 3 versus 2 tier. We're leaning towards the 3 tier today and looking at where the context and semantic integration is going to live inside of databases, or continue to be a blend with the virtualization technologies.
Wow, that's great stuff. And now, your next guest, Walt Mcguire. I'm going to hand the keys over to you. Just click anywhere on that slot and use the down arrow on your keyboard. The floor is yours.
Great, thanks. Thanks for the introduction. First of all, can everyone hear me okay? Can you guys hear me all right?
You sound good.
Okay, great. So what I'm going to do for the next, say, 20 minutes or so is talk about an example of an analytic platform. So that's what ParAccel is about. That's what we build. I think there are 3 topics I'm going to cover. And first, what's interesting is I didn't see your presentations before we talked today, and I think it's great because you read our minds or we read your minds, because it's spot on. The messages you were delivering are spot on with what we're doing. So let me take a few minutes and go over first what ParAccel is and what we mean when we say analytic platform, and then take a few minutes and talk about a specific example of how we integrate well with Hadoop, and a little background if anybody wants it on Hadoop. And then I'm going to talk about Odi Services, and I'll explain what the concept is and where it fits in just a moment. So first, what is ParAccel? There's a lot on this slide. I'm a keep it simple guy, so I'm going to distill this down to 3 things, and then I'll go into a little bit of detail there. First, ParAccel at its heart, is a database. That means you use SQL to interact with it. It means it's got tables and rows and columns, and if you want foreign keys and all that good stuff. It uses a columnar engine. So that means we store columnar, we do encoding and compression on those columns, and all that good stuff. We've got patented technology around executing compiled queries, SQL optimization. And for anyone who's ever worked in an MPP database, you know that distributed execution plans are a very thorny problem. Having a system that's smart about determining the best way to execute a distributed plan is very important. We've done a lot of optimizations there. Just for those of you on the WebEx, I'm referring to the analytic engine section right now. The communication optimization, another weak point in an MPP system is very often the interconnect between the system. And this will make more sense for those of you who may not know in a moment when I go to the next slide. We've done optimization there, and that's working out very well for us in a couple of different senses. What this enables is scale. So if you think about the problems in big data and needing to run an analytic platform, the first thing is we have to be able to scale the data. So you have to be able to start, if you're a new company, maybe you're getting a gig a day of data that you need to bring in, and you load it once a day. And if you're a success, in a month you're getting a terabyte a day, and in a year you're getting 10 terabytes a day. So there has to be an ingest ability to load it, to acquire it, and to store it at scale. That means the analytics need to scale. Sampling is a huge problem in the analytics space, especially in instances where you're looking for the exception rather than the rule. You can't sample in that case because you might miss the exception. So we need analytics scale, to be able to run analytics at scale. And finally, users and interactivity. So we have to be able to actually handle a lot of users, tens or hundreds or thousands of concurrent users, as well as answer questions quickly. I already heard a couple of comments today, and I hear this every day in the field, that the latency issue on Hadoop is a constant problem. I just want to ask a quick question, and I have to wait half an hour to get my answer. So being able to interact quickly with the data and ask questions of it. So we're a database. We're a software-only MPP solution that allows scale, enables scale. And the third piece, and this is kind of the apex of the pyramid, is we're an analytic platform. So that means that we built a set of APIs into ParAccel, which allow us or third parties or our customers to extend the analytics in the database. So today, right now, we've got a long list of integrated analytics. I think it's north of 500 now that do things as mundane as basic statistics to k-means clustering and linear and logistic regression. We've got a library of analytics we're actively researching and growing here internally. And there's a set of, the APIs are there for people to roll their own if they care to. And the other piece, and this is I think where the fulfillment of the analytic platform becomes real, is what we call on-demand integrations. So this is utilizing our APIs, and this allows for the development of the high-speed, parallel, easy-to-use interfaces with arbitrary data sources. You see a partial list there on the left. These are things that exist today. You can use them today. And I'm going to talk a little more about the Elastic ODI, the ODI services, and what's coming. The way we see this when we say analytic platform is that it fits into an ecosystem. And I've already heard some comments on that. We call this cooperative analytic processing. I've been in this space since big data meant a megabyte. And every vendor I've worked with up until ParAccel has had this vision of their platform is the platform. They're going to take your stuff, your data, it's going to go into the vault, and then you need the combination to get it out. Our approach, we call it cooperative analytic processing, is to make it more like your data is on the shelf in the library. So if you need to collaborate, if you need to share data, it's easy to get at. You can acquire it easily with on-demand integrations. You can enrich it or transform it in the database. You can run complex analytics on it, and you can interchange that data very easily with your traditional data warehouse that you see on the left, as well as analytic applications that we're starting to see emerging in the Hadoop space on the right. So specifically, with regard to ODI services, what these mean, what these represent, is the ability to share both data and processes in both directions, so they're bidirectional. And I have a lot of meat behind this. So I'm going to talk function for a moment, and then I'll talk architecture next. It allows you to transform incoming data for analytics. What we find a lot is the raw data might be Apache web logs. What I need to do is I need to sessionize it. Once I sessionize it, I need to determine characteristics of sessions. Once I got those characteristics, now I can apply them to users and develop a profile. That's what we mean by transformations. It allows you to leverage arbitrary programming languages, and there's a long list. It lets you persist or stream data. So you can bring it in and persist it, or you can stream it straight through. And this may be one of the big points for CIOs and IT directors and such. You can rapidly build these modules. This is not, we're not talking months, we're not talking weeks, we're not talking days, we're talking hours to build and deploy these. So a little peek into the background of why we discuss an ecosystem. Our approach is that the workloads should gravitate towards the right platform. So I'm glad you guys already talked about the Hadoop elephant, so I don't have to explain why I have a picture of an elephant on my slide. But I started dealing with Hadoop back in 2009 here in the West Coast. Nobody knew what it was, and between then and now, here in the Bay Area in Northern California, it's on fire. Everybody's experimenting with it. They're using it for archiving. I meet people daily who tell me they have a petabyte in Hadoop, and they, for various reasons, they can't leverage it fully. But it's good at certain things, text search, text analytics, doing certain kinds of transforms. They also have a traditional data warehouse, an Oracle, a SQL Server, DB2, and so on, where they report, they run dashboards, all this kind of standard things. The gap is the analytic database. So very interesting that we were just seeing that presentation on the three-tier architecture from John. So our approach to Hadoop specifically, and the best way to do analytics on Hadoop data, is driven by my own experiences and those of the engineering team here. It's easy enough to write some kind of an adapter, something to go to the cluster, go to Hadoop, ask a question, and then you wait, because there's a petabyte and you're drinking it through one connection. So you're drinking the ocean through a straw. So our goal and what we built is to create a high-performance, node-to-node, bidirectional connection between Hadoop and the analytic platform that can share data and processes. And that way, they're joined at the hip so that they become an extension of each other. So you can utilize the language that almost every analyst today knows, SQL. So this is an example of how the process works. And I'm going to start at the bottom of this slide and tell you what you're seeing. On the left side there, we depict a very high-level ParAccel cluster. The right side, we have a high-level Hadoop cluster. The way this is set up is there's an ODI component installed within ParAccel, and then you install an ODI manager component on the Hadoop cluster. That way, when you run that query that you see at the top there, a read from Hadoop, for example, what's going to happen is the UDF in ParAccel is going to instantiate a connection with the job tracker in the Hadoop cluster. It's going to pass information about connectivity and the nature of the job, the location of the information in the Hadoop cluster. The tracker is then going to distribute that information out to the various processes across the cluster. Each of those mappers is then going to establish a connection back to a ParAccel node. And they will do many to one because, of course, we have a lot of situations where I'll have a 1,000-node Hadoop cluster and I have a 10-node ParAccel cluster. So we have to support a many to one, and it self-optimizes to balance things. At that point, the mappers will then stream their data in, and the ParAccel database now returns the record set out to the user. The write to Hadoop is the inverse of that process, and I think the key point to call out here is the level of interactivity between the two. I've worked with other ways of doing this. One of the things that got me the most excited about ParAccel is this right here, because getting that data out is very difficult. And getting the data back around when you have things like an analytic loop has traditionally taken a lot of extra effort, right? And a good example of this is if you think about that Apache weblog example, I pull the data into a ParAccel cluster. I have to enrich the data. I have to run some analytics and apply some things. Then I have to write that back out to Hadoop, maybe for job control. Maybe I've got a subsequent job that has to execute. Maybe it's actually more interactive than that. Maybe I've got information that's actually going to be fed out to a tier of game servers. For example, if I'm running a social game, I have to update that information in the cluster and it has to go back out to the game. So this supports those analytic loops, makes them very easy to set up and run. Again, I think you guys were telepathic because we've actually been working on HCatalog integration. And the interesting thing is I had some speaking notes and I was going to explain what HCat is, but it sounds like I probably don't have to do that. For those of you who didn't Google it, it's a storage management layer for Hadoop that gives you some metadata and abstraction. It lets you query more simply. So for example, you can query Hive data without needing to know the schema up front. Things which we take for granted in databases, but which haven't been so easy traditionally in Hadoop. It also lets you bring in CSV and JSON files, and it just generally makes it much more usable. This also allows for ODI scan filters. So for example, if I'm going to query a 10 terabyte Hive table, I can put in a predicate, a date predicate. And if the data is partitioned that way in Hive, this will pass the filter through, and it'll actually limit the amount of data that it has to scan through. A very nice little performance enhancement for situations where you're working with very large volumes of data and you don't need it all to come across the pipe. And the whole point here is first to simplify the investigative workflow. I've heard again and again that people have 1 or 2 or 10 petabytes of data in Hadoop. Because they don't want to throw it away. I think I just heard that debate. We talked about that, right? Should I keep it all or should I keep just what's relevant? Some companies are erring on the side of keeping it all. And so they just shove it all in Hadoop and hope they can get it later. We're going to simplify that workflow with the Hadoop ODI and also simplify the development of integrations by making them easier to write and easier to execute. What I'm going to do now is transition over to ODI services. So that was a specific example, an ODI we wrote for Hadoop. What we recently announced is the Odi Services Product. And I realized after I wrote this presentation, I didn't actually explain what it is before I go into the architecture. So let me stop for a moment and explain what it is. Before ODI services, if you wanted to write an ODI with ParAccel, you need to fire up your editor and write some C++ code. Not the biggest obstacle in the world, but it wasn't as easy as it should be. So we built ODI services first and foremost as an abstraction layer, but it also is it's a service layer. It's much more than just an abstraction. So that means it takes care of parallelism for you. It means it takes care of installation and setup. It provides a common way of interacting with the service layer so that you can focus on the business need, getting the integration done, getting the data in and out of the right place. So what you see here, again, is a different view of a small ParAccel cluster. And on the lead node, you see ODI services and service management and context. This provides a progress and status. It coordinates installation and logging. It also determines optimal execution plans for processes that come in via ODI service calls. If we drill into a compute node, what you see here is very straightforward interfaces. You're going to write maybe a Perl or a Python or Java. If you want to write R, you can write it in R. And you read from standard in, or you write to standard in, you read from standard out, and you monitor standard error. You can access metadata and control your processes through the management framework. This way we abstract you from needing to deal with all the details of ParAccel. Developing an ODI basically it's a matter of either it's a command line executable or it's an interpreted program such as Perl or Python. This is the process of developing and deploying an ODI. I wanted to make a busier slide, but I went through this with the engineering team, and this is as complicated as we could make it. Write your script, test with our harness, load to the lead node, and you're done. Very straightforward. You know, the nice thing about the test harness is it'll test it against the ParAccel database, so you know you're getting the right thing. You're not mocking anything up, or you're not playing with phantom data. What it does, I apologize, this slide is mistitled. What this does for you, for the developer needing to do this, it's going to enable a lot of use cases. The analytics world is very fast moving, and by nature it changes quickly. The data changes, the velocity changes, business users are always asking new questions. So you need to be able to you prototype quickly. You have to be able to write one-offs. Today I'm bringing in data from Salesforce, and tomorrow they call me and tell me I have to write an Omniture feed. And then you can productionalize these things. And I think most importantly for me, having wrestled with this my entire career, you can get data out too. We make it easy to bring things in, process them, and then push them out to something else. You don't need to write C++. If you want to, you can, but you don't have to. You don't have to deal with the complexity of the database. You can develop these things as quickly as you can write the code. You can bang out some Perl and get this stuff done in a couple of hours. The database takes care of the parallelism. The protocol is very straightforward. You're working with standard in, standard out, and standard error. The system coordinates logging, which in a small cluster isn't such a big deal, but if you've ever tried to diagnose a problem on something like a Hadoop cluster when you've got 500 nodes, without central logging, good luck trying to find what's going on. And monitoring progress, so you can actually track where your jobs are at. And so what does this enable? What can you do with it? This gives you a flavor for what you can do with ODI services. Event capture. So you've got a big systems infrastructure. You have to capture a lot of events and keep track of what's going on. Or you're an application company, and you need to capture a stream from your applications. Maybe you're a hardware vendor, and you've got to capture a constant stream of things coming in from your customers' installations to know what's going on. Maybe you're a smart meter company. You can bring in that data, and you can do near real-time analytics on it for things like quality of service. If you're a Walmart, you can capture RFID tag information in the factory and store that. My personal passion is I like a lot of the social stuff. I've worked with a lot of the social gaming companies here in Northern California. So query Twitter, bring in Facebook data, or read from consolidated social streams. Why stop there? Why not go to Salesforce and get the Salesforce information, or Eloqua? Why not query Omniture? And then, the nice thing about an analytic platform is it's extensible. We can start to deal with semi-structured data. So you can do things like take what I call semi-structured, say Gmail, and you've got a bunch of information. Maybe your Salesforce uses it. You can bring that in, and now you can get some real visibility across what's going on. You can tie Salesforce opportunity to email traffic to social data, all in one platform. Okay. And the endpoint is at the bottom there. That's embedding this in business processes. So I've got a call center, I've got a distribution center, or I make a piece of hardware, and the hardware has to get some near real-time answers on likelihood of failure. All these things are now possible with ODI services on top of the platform we built for high performance. So for us, the way we view it is that cooperative analytic processing is really the future of analytics. It's not going to be one thing. It's going to be a few things, and they solve different problems. But in the end, there has to be a very high level of interactivity in different contexts. We need batch, we need daily, we need hourly, and we need near real time. So that's the end of my section. I guess I'll turn it back to you, Eric.
All right, that's a lot of great detail. Thank you very much for putting all this together. I guess before we go to audience questions, let's kind of talk with our analyst friends, and I guess we'll go in the order that they presented. So, Mark, first I'll ask you, this looks pretty comprehensive to me. Is there any piece that's missing from your perspective of what you'd really want in the ideal analytic platform?
Missing pieces. There's always missing pieces in an analytic platform. The question is really what your definition of platform is and where you draw the boundaries between services. this definitely provides all of the lower-level platform perspective and shows some of the semantic, semantic in terms of data semantics, not, texty word semantics, kind of integration across things. I think, where it gets interesting is understanding where data is, comes from, goes to, and, obviously it takes a lot more digging into the details to understand and manage that aspect of it. And so when I think of an analytic platform, one of the things that I think of is what lives also one layer above what we were just looking at, or what you have on the screen here, which is the data management layer that kind of knows what's where, the lineages of things, the metadata, whether it's tabular or non-tabular, that sort of thing. But the question then is, who provides that? Is that something that should be provided by the base platform provider? Is that something that should be provided by a secondary party? Is that something that evolves over time in one or more of the platforms in a distributed fashion? Kind of goes to John's slide about sort of vertical or horizontal in terms of the tiering.
Yes, those are all good questions. And maybe, Walt, do you want to comment on that, and then we'll bring John in too? Sure.
Excellent points. I think, as I listen to the question, so the first thing it could open on a much broader discussion of who solves what problem. For me, it's the place I start is by reminding myself that the analytics space, even though Teradata has been around for a while, the big data analytics space is still very young. We're going to see a lot of change and evolution in this space. We're going to see a lot of consolidation in this space. I absolutely think that there's a very interesting challenge, because I've worked with shops doing multi-terabyte and petabyte clusters where data lineage and knowing what happened to it is a huge problem. And they solve it with elbow grease. They solve it with job tracking and so on. I can't say that there's a near-term answer in my head, but it's definitely an issue.
Yeah. Okay, good. I'm going to push actually this slide as well, because this kind of talks about how you bridge these two worlds, right? And this is very simple insert command, very simple select command. I guess I'll bring John O'Brien in. What do you think, first of all, about that first question about missing pieces? And then, if you would, comment on the slide right here, because I think this really is part of the magic that we're talking about today.
Yeah, actually, it's funny that you came back to this one. This is one that I was going to actually comment on. One of the things that, and I think with the architectures, it's really one of those things we're going to watch play out over the next year. We saw a lot of changes this year, especially with the H-catalog implementation that happened in the summer. So that enabled a lot, and now we're seeing the next step. So with the ODI, what I like about ODI as a, if you will, toolkit that allows us to build connectors. If we need to connect somewhere, we can get it, so data's not really locked up. But when you connect into something like a Hadoop environment, I like, having been in that MPP world for so long, it's always about pushing the analytic to the storage level. You don't want to bring the data back. So I do look at how do we take the routine or the result and get it executed in maximum parallelism. And I'm looking at orders of magnitude, really, where the Hadoop environment is an order of magnitude larger than the analytic environment. That low-cost, high scalability benefit of Hadoop where, and I'm one of those that say dump all your data there, just go for it. It's low cost. It doesn't get any cheaper than that. The advantage is you go in there and you mine out valuable semantics and valuable analytics that you want to use, but then move it to the, the optimized platform, that analytic database that will run that faster than Hadoop will. But from a discovery, I don't want to put unknown value data into a expensive platform, if you will, relative cost. So in this slide, what I like about, I've always been a fan of, federation within databases and the transparency. I like that we can, push data down or push the function down into get executed in Hadoop. I do have some concerns about, my result data set being tens or hundreds of terabytes and returning that. I mean, even it's very efficient the way they've laid it out here. So it's a really good design. but I'm not so sure I want to move around, 50 terabytes between environments in an iterative fashion. So I think leveraging either the HCatalog to benefit from integrating the data, or I think in the ODI case, you can also build that to connect to Hive. If you want to leverage it through Hive or through HCatalog or through any other system, it's going to be a big benefit. But I wonder about pulling that much data back from Hadoop into an analytic platform.
Interesting. Walt, do you want to comment on that?
Yeah, I mean, it's a classic problem of, we give the user the keys, and what are they gonna do with it? I guess the first is that the point is for scale, and so if we've designed a proper network, if we expect 50 terabytes, we can plan for 50. So that's the first thing. It's really a question of expectation versus what the analyst is going to run. I think the question of pushing down predicates is a good one. We do that with the HCAT integration today. So when the data is partitioned appropriately there, we can do it. I think I actually made a note to go dig with engineering to explore the possibility of making sure the HCAT integration is going to do something like maybe some predictive information about how much data it's going to bring back. So that's my enhancement request for the day.
And actually, that's a really good point, because whenever you get into this cross-platform database federation type architectures, the lead database platform really, without analyzing statistics, has no idea if the data, if it's hitting a table that has, a trillion rows in it or 10,000 rows into it, but it's that kind of what's behind the wall there that the lead database has to have some way to determine quickly.
Yeah, we've had a lot of dialogue about that. I mean, what it really opens on is it really opens on the question of extending an optimizer to be more than just on top of a database, right? We're talking about extending an optimizer to now have visibility across things like Hadoop.
No, absolutely. It's all about your optimizer being, and this is where I think differentiates products, by the way, that, is having a great optimizer that can extend and do extremely good execution plans. And part of that is having the statistics to know how to design the proper execution plan. So, I mean, I do like that. I know that with the parallelism, you guys are going to be highly efficient pulling that data back. As a user perspective, I'd make sure that we understood the proper use case of when we wanted to iterate that way or when we wanted to push down the predicate, and just, when you turn on that capability, they could be moving a lot of data around on the back end, and maybe unnecessarily. So it's more of an implementation user beware type of thing too.
Yeah, interesting.
Yeah, it's half that. And
yeah, go ahead. Walt? Did we lose you? John, are you there?
I think he's on the phone with engineering right now.
That's interesting. Here's a, oh, go ahead. Are you there, Walt? He must have dropped off.
But I was just going to add that it looks to me like ODI as a developer toolkit. And
can you guys hear me okay? I think I just died.
Yeah, no, there you are. We hear you.
Here we go.
Okay, so actually there's a good question here from the audience. Let me throw it over to you, Walt. One of the attendees writes, 529, lingua franca of analytics, SQL. And he says, I see SQL being more used for basic descriptive statistics versus predictive analytics. Can you comment on SQL as the lingua franca and its limitations?
Sure. So, wow, I can hear an echo of myself on the background.
Yeah, hold on one second. Okay, go ahead.
So I've worked with SAS and Stata and Clementine, so other data mining languages. I get the question. SQL, if you're coming to it from the world of I'm going to write straight queries and just ask questions for things like reports or output, it makes total sense. There's an adjustment, and it's kind of a paradigm adjustment. You have to get used to the fact that SQL can do things it couldn't do 5 years ago. You can run table functions that will do things like sessionize, which if you ever tried to sessionize data back in, say, 2006, it's rough, right? It does a lot of new things. There's a bit of a learning curve you just have to overcome to become comfortable with table functions and UDFs and incorporating those in. the bar is not too high. If you're used to SAS, that's a bigger jump. So there's definitely a curve there. What we find is that most of the people we speak with they're not necessarily the hardcore SAS folks. They're more like the report writers who've been pressed into service doing big data analytics, because 3 years ago they weren't, and now they have to learn that stuff. And they know SQL, and they can get on with SQL quickly.
Okay, good. Here's another good question, and it's actually one that I was going to ask, so we have a lot of mind reading going on today. One of the attendees writes, given the pace of open source development around Hadoop, is there really a robust future for separate external analytic platforms, or more precisely, what are the use cases where this will be a necessity? And it reminds me, we had a webcast yesterday, you mentioned Teradata, and Imad Barudi was on the show, and he said a couple of very interesting things. He said that there's so much that you can do around trying to integrate the worlds of business intelligence and big data analytics via Hadoop. I mean, there's just a laundry list a mile long of the different optimizations you could do, connections you could make, services you could provide, and so forth. And he said what they're doing is taking a very careful, customer-driven approach to what they build and what they don't build. So I think that the question the attendee is asking here is, with all this innovation coming around in the open source movement, how are closed source vendors or for-profit vendors like yourselves going to constantly deal with what's happening in that open source environment without sacrificing some of your market share or some of your revenue?
Yeah, so it's a good point. But I think it's worth starting by differentiating, that the fact that open source can produce something quickly by the fact that people may or may not adopt it quickly. Right. I've played with open source on and off for 20 years, and I was downloading Torvald's stuff when he was at University of Helsinki, and that can be a long gap. So somebody can release some code today, and 2 people might download it, 100 people might download it, but it's going to be a year before anybody puts it into production. So for us, I'm not the CEO, I can't speak to company strategy, but like most organizations, we go by what we see in the marketplace. What we see today is that people are using a lot of the core Hadoop functionality. They're using it for archival, they're using it for ETL, maybe a little bit of straight query stuff in Hive. Maybe they put their toes in the water with Mahout, but they're not doing the full-on analytics yet. So we tend to go where the demand is, and then the idea is we think 1 or 2 years out.
Yeah, okay, that's good. That's a good comment. And I guess maybe Mark, I'll bring you in on this one as well. On this question, it is always about the size of the community of developers who are working on stuff. I mean, that's really what drives a particular platform over another. What do you see just happening in the marketplace of open source around big data analytics, and how disparate is the open source movement with a lot of the stuff that's happening around it?
Well, I think there's 2 different questions in that. One, you're talking about the people building the ecosystem, and the other is the people who are making use of it. Mm-hmm. And obviously there's a fuzzy boundary in between. So which area are you talking about?
I think I'm talking about the second area.
The second area being the users and developers of it.
Exactly, yeah.
Yeah, I think the thing that I liked about Hadoop, and I started toying around with it about the same time as Walt did in 2009, was the freedom that it gave me to process data in different ways that I couldn't easily do before without either specialized knowledge or really strict limitations or expensive tools. And so I think in sort of a classic sense, it was competing for an audience that was underserved or not served, all of the developers out there. And part of it goes back to that SQL question. SQL is great for storage and retrieval, and it can be extended set-wise to do some things, but it's not a great computational processing language or framework. And so we've opened up the doors to a huge community of people now, and we can do things that are more complicated than what you can do in SQL, but are probably, in some instances, or maybe a lot of instances, less difficult, challenging, or complex than what one might do in a SAS or an SPSS environment with a lot of hardcore algorithmics people in there. Or on the open source part, to kind of answer that question, there's a lot of people experimenting with new algorithms, new ways to do various types of statistics or machine learning problems. And they're able to code that stuff up at the extreme high end, and everybody is able to build and share this stuff on top of that platform. And I think it's just created so many more people doing so much more stuff that, it's finally rejuvenated kind of a stagnant BI and data warehouse market.
And they are very different use cases. I mean, I put up this Odi Services examples page, and maybe we can talk about this for a couple of minutes, because I think one of the big challenges is for people to wrap their heads around what kind of applications they can build, which kinds of questions they can ask. You have to know the realm of possibilities, or at least have some idea about it in order to start formulating new kinds of questions. So maybe, Walt, we'll bring you back in. Can you talk about a couple of these things, like maybe pick event capture for starters? What are you talking about there, and what are you talking about being able to do?
So, when you're talking about a stream of events, sometimes you're looking for exceptions, sometimes you're looking for trends. And so a simple example, probably one of the more common ones I've heard here in the Bay Area, like a web events or web application events. So worked with Zynga a lot, and they stream through a lot of events into their database. And they want to know, with as little latency as possible, what's happening, what changed, what events are triggering problems or churn or things like that. And the challenge there is acquiring it quickly and being able to answer questions at scale. So the ODI service in that case is going to be pressed into the task of actually capturing the data and streaming it straight into the database from a source. So you can have something like it would listen on a pipe, and you just have your application layer just write data straight through in a stream.
Okay, good. And we have a couple more questions from the audience, so let me just throw this one in. In terms of deployment, on-premise or cloud, I'm guessing you can do both, right?
Yes, yes we can.
Okay, and then competition. There are a bunch of different vendors doing fairly similar things. Who do you think are your closest competitors? And one of the attendees wants to know if you consider yourself a competitor with Aster Data. What do you think about that?
So, what we see the most are the HP folks, HP Vertica a lot. We see a lot of IBM, IBM Netezza. And, beyond that, I can't say I've run into a lot of them specifically.
Interesting. So
I mean, I get a lot of, here in the Bay Area, I get a lot of questions about Hadoop. I think, that's normally people who have just downloaded it yesterday and haven't experimented with it yet, because 3 months after they've been working with it for 3 months, they don't ask anymore. They know that Hadoop is good at what it does, and an analytic database is good at what it does.
I've heard some interesting comments about ways to use Hadoop, and one of the more fascinating theories is that you could use Hadoop on the front end of your information architecture to literally soak in everything before you process in traditional ways, like loading it into a data warehouse or some other kind of environment. And that sounds like if you have the resources to pull that off effectively, it would be an interesting thing to do, because obviously with Hadoop and with the cost of storage these days, you can store tons and tons and tons of data. It's not so much a storage issue anymore. But have you seen someone take that kind of perspective, or is that a bit too much?
I think it's increasingly common. There's this adoption curve for Hadoop users that, and I think in the Bay Area we've got a community that's pretty far along. A lot of people picked it up and started playing with it 3 years ago. Now they've been using it for a while. So there's absolutely that use case. There's this notion that they'll acquire it, and Hadoop is good at doing things like I've got a bunch of text documents, and I don't even know what my schema should be. You can bring in some algorithms there, and it makes sense in a batch process to process that, figure out the schema, figure out the associated numbers with that schema, now bring it into a place where analysts can actually interact with it quickly.
And what about different distributions of Hadoop? Because you have a Cloudera version, you've got Hortonworks doing a distribution of Hadoop. Of course, you've got the sort of pure Apache version. What's your take on which one to go with, and what are the advantages or disadvantages of each?
So hard to comment on particulars of all the vendors, but I can tell you that you know, the three we probably hear the most are Hortonworks, MapR, and Cloudera, not necessarily in that order. You know, Cloudera's got a lot of market share, so there's a lot of discussion with them. You know, and what we're aiming for primarily is to work with the enterprise Hadoop offerings, because I mean, we're a software vendor, so we want to work with the folks that are going to you know, be in the enterprise, and we're going to be next to them.
Okay, good. And Mark, I'd like to bring you back in because you had mentioned something the other day that I thought was very interesting. It's I think a speech that you saw about big data and the promise of big data, and you said it wasn't a very technical person, but you offered a very eloquent presentation on the sort of long-term promise of big data, being able to provide the kinds of contextual insights that we always wanted through business intelligence and data warehousing, but hopefully finally getting that big picture and granular detail combined. Do you want to comment on that? Because I thought it was a very interesting concept you were talking about.
I don't remember what we were talking about.
Well, that was the gist of it. And what I find kind of interesting is if you think about the way you have to process data to fit it into a data warehouse, you have all this, you know, third normal form stuff, a lot of data cleansing, data quality. You're really trying to strip out a lot of context, get it down to its core value, and then later on down the line, you kind of pull it all back out and try to get a big picture view of stuff. And it seems to me that big data has the potential over time, I think 2 to 3 years from now maybe, of being able to deliver the kind of insights we want without having to go through all that painful massaging. But what do you think?
Well, yeah, I think that's part of the, you know, whether it's tiering the technical architecture like John was talking about, or the data architecture, or distributing data across platforms like you saw in Walt's presentation. It's that we've had this assumption for a long time, which turns out to be completely wrong, that you can somehow build an enterprise data warehouse that has a single consistent view of 100% of the data, because that's like building a consensus reality. And, you know, data is used contextually, and what's good enough in one place isn't good enough in another. And it presumes when you start looking outside your core applications that you can actually model 100% of everything. And you, meaning you, the data architect or the data modeler or designer of the analytics platform, you know, there's a lot of limitations being imposed at that point, and you have to strip out things, and you lose important little bits of information along the way, and where and how something is used as you try to provide something that's least common denominator for everybody. And I think that's the flaw of the old architectures. And, you know, now we do have that ability to keep everything and find most of it, hopefully, if we manage it properly, and integrate more on the fly and surface things instead of the old use case. And I think the old use case, too, was monitor known situations, look for exceptions or deviations to those things, and then do a little bit of exploration of data around them. And that's a lot different as a use case than provide context for what's happening, or uncover via descriptive statistics unknown patterns, or try to build predictive or optimization models over things that require changing information, because every time you change the system, you change the measurements you're collecting, you change how things are happening, and you have to go back and resample that data. And that sort of change and dynamism isn't what data warehousing and BI were all about.
Yeah, that's very interesting. And John, I just put this slide up here because I think this really is kind of the big picture view, at least what I've been thinking about here, talking about semantic integration of data. And it does speak to the problem that you have of trying to integrate all this other big data into this sort of, I don't want to call it an old world way, but a more traditional way of building an enterprise data warehouse. I mean, it's almost dizzying to think about the number of things that are changing right now, and at a certain point, a model just doesn't work well enough to provide value anymore. I don't think we're at that stage now with the data warehouse, but can you kind of comment again on this slide here and the importance of semantics and the importance of knowing when and where to use which kind of technology and how to synthesize it all?
Yeah, sure. I think one of the things we've been touching on when we talk about context or semantics, the beauty and the great thing about the enterprise data warehouses are that you take that context and you incorporate it into the data model, and therefore it becomes merged with the data. And the value of that won't go away is the fact that once we have a certain model or a context, we want it to be consistent and shared with as many people as possible. But when you have data that is mapped into a certain context of data models, you also strip away the ability to have an unbiased look at discovering new patterns. And Hadoop, being a schema-less type environment, really allows for business analysts, data scientists, people in the organization to work with information, try out very quickly in HCatalog or something like that to say, what if I try this, semantic interpretation of the data? Does it work? Does it fit? Nope. Well, then just delete, if you will, that semantic perception and then create a new one. So it allows for that high agility that we want. It strips away a lot of the biases of data models and business rules to really discover new things, whether it's from a statistical routine that discovers a pattern or from an analyst that has a hunch and wants to just discover something. They could try it out in a virtualized environment like HCatalog. And once, I believe the methodology works, that once something is identified of value, then you can move it into some of the structured environments and share it with more people through standardized tools that are very SQL-based. In the middle there's just no question that the analytic databases are optimized for executing this. I agree with Mark that this is not what the traditional databases were built to do. It's never been a good match for the BI industry for the types of questions we want to answer and discover in the analytic models. The analytic databases are built to execute and perform those kinds of functions. And once you discover that, incorporating the together, BI is really going to occur in that middle tier of analytic databases going forward.
Yeah, I think that's exactly right. And Walt, I'd like to throw another question out to you. And folks, if you arrived late, we will archive this webcast. The archive is usually right up very shortly after the event. You'll find it at insideanalysis.com. Look under Webcasts, under Hot Technologies. And Walt, I'd like to bring you in just on one last maybe closing section here to talk about what John just mentioned a moment ago, which I really see as a huge area of promise for this big data analytics discipline, and that is the playground, just being able to play around with stuff without the constriction of some kind of model or the constraint of having to define a data model, and be able to make new discoveries, just find new patterns or new insights, and then, as John suggested, take some of the insights from that process and use that to build some more traditional BI-type tools to really empower your business analysts or your line of business people, your directors, or whomever. Is that something that you see being the case, and could you expound on why or why not you think that's the case?
Yeah, actually, it's a great point. One of the, I think, unintended consequences of a good analytic DBMS is that the first thing a lot of people are trying to solve is some kind of, it's an evolutionary problem. It's my reports aren't fast enough, or I need to acquire the data faster. Then a few months after they have it installed, they discover that, it's so fast and I can scale so well, maybe I can create a sandbox. And in fact, that's what our customers they're inclined to do. They actually are setting up analytic sandboxes just for this purpose. And what we're already starting to see is they're leveraging the Hadoop ODI specifically for that cycle, so that one of the problems you have is you might have some data scientist types who are they're the Java guys. They're going to write the MapReduce code. but you might have a group of analysts who are very capable folks, and what you don't want is the latency of having the analysts have to ask the Java folks to write a job to get the data out. This is where the ODI comes in handy, and it's not a full-on solution, right? MapReduce there are certain things it's very good at, and we don't pretend to replace that, but it does simplify the challenge, and in fact, that's what our customers are starting to do.
Okay, good. Well, I'll tell you what, this has been a fantastic webcast. Thank you to both of our presenters today in the analyst world and to Walt from the vendor world. As I mentioned, we will archive this webcast for later viewing. This is going to be a new kind of webcast that we'll do intermittently over the course of the next couple of years. The idea is to get different perspectives on a particular discipline or concept and then bring in a vendor to offer their particular version of what that might be. So Analytic Platforms was today. We will have one last briefing room of the year next Tuesday with a company called Xero. That's definitely going to be worth checking out. We'll also have one last federal spending episode next week. That's going to be on TARP, the Troubled Asset Relief Program. I just love that stuff. So, folks, with that, we're going to bid you farewell. But like I say, we will archive this at InsideAnalysis.com. Check it out there. And until next time, thank you so much for your time and attention. We really appreciate it. Speakers hang out for a quick post debrief, and that's it, folks. Thanks again. Take care. Bye-bye.